Hi, welcome to this very first module of the course on signals and systems. In this module, we will be learning about signals in general. To begin with this course, let's ask ourselves a simple question. The question is, what is a signal? What basically is a signal? Well, to put it in very simple words, it is a set of information. It is a set of information. Information? What information? Well, it depends. It depends on what kind of signal it is. Let's take an example. Consider my voice that you are hearing right now. It is an example of signal. What information does it carry? Well, it carries the information regarding the acoustic pressure. Acoustic pressure that my vocal cords in my throat experiences as I speak. In order to get a feel of how this voice signal looks like, let's observe the graph shown on the screen. The graph here shows real-time representation of my voice. You may observe that my voice changes and this graph also takes equivalent values. Let's observe this graph more closely. With respect to this graph, we may interpret this graph as a plot where the x-axis represents time, whereas the y-axis represents the strength of my voice. Let me indicate them. X-axis denotes time, that is usually measured in milliseconds, whereas the y-axis indicates the strength, or also called as the amplitude of my voice, usually measured in millivolts. With respect to this graph, let's make a couple of observations. If we have a look at this graph, we may see that the values of this graph or my voice changes with respect to time. We may see that my strength of my voice changes with respect to time. Let's write that. This amplitude changes with respect to time. Therefore, the amplitude is also called as a dependent variable. Why it is called as dependent variable? Because the amplitude changes with respect to time. Therefore, the amplitude here becomes the dependent variable. On what it is dependent on? It is dependent on time. If we consider the time itself is an independent entity because it is not dependent on any other variable. It is an independent entity. Therefore, it is also called as an independent variable. Independent variable. Therefore, we may see that a signal is a kind of dependency or a kind of mapping between the independent variable, that is time, and the dependent variable, that is amplitude. We may see some kind of mapping here. For example, if we consider a value here or there or there, each of these values are dependent on the time. Therefore, this signal can be interpreted as a mapping between the time. Say for example, let this be 1 millisecond, let this be 2 milliseconds, let this be 4 milliseconds, and so on. Let the amplitude be, say for example, 1 millivolts, 2 millivolts here, and say 8 millivolts here. This signal can be interpreted as a mapping between this time variables and the amplitude here. So you can see there is a kind of mapping here. So let me write that. Signal is a mapping between independent and dependent variables we denote this mapping something like this. The signal S equals to f of t. This is the notation for signal. What the S indicates here? The S indicates the signal amplitude. The signal itself, or the amplitude, signal amplitude, whereas the time here indicates the independent variable, time independent variable. The signal or the amplitude here is a dependent variable, whereas this f indicates the function or mapping Therefore, this notation says that this signal is a function of time. In this example, we have seen that my voice is dependent on independent variable, that is time. However, there may be multiple such independent variables. In voice, there is only one variable, one independent variable, that is time. However, there may be multiple independent variables also. The number of independent variables are also called as dimension. Let me write that. The number of independent variables is also called as dimension. Therefore, voice is an example of one-dimensional signal. Let me write that. Voice is a one-dimensional signal. I'll indicate that by 1D. And the independent variable here is time. This is time. In this example, we have only one independent variable. As I said, there may be multiple independent variables also. Let's take an example of that. Consider that if you click a photograph or a picture with your camera, something like this, this is for illustration purpose only. If we look at the image, the brightness or the intensity of each and every element of this image varies with respect to the position in this image. For example, the intensity here could be different from the intensity here. Therefore, the intensities of this image elements depends on the locations of those elements. The locations here are indicated as the horizontal and the vertical variables. The horizontal usually indicated by X, whereas the vertical one indicated by Y. Therefore, we may say that the image is a function of the position of the pixels denoted by X and Y. So X and Y here indicates two independent variables. Therefore, image is an example of a 2D signal. Let me write that. Image is an example of two-dimensional signal. What are the dimensions here? The dimensions are the locations or the positions of the pixel elements or the picture elements, which are usually indicated by X, Y. Like such, we may have multiple dimensional signals also. However, in this course, we shall be dealing with the one-dimensional signals. We may have other examples of one-dimensional signals here. The other examples includes, let me give an example of, let me write there other examples of 1D signals. The first example that I would like to consider here is the electrocardiogram signal. Electrocardiogram signals, also abbreviated as ECG signals. Let me show you an example of this signal. A typical ECG signal looks something like this. This ECG signal is recorded as an electrical activity from heart. Therefore, the variation here indicates the electrical activity or the heart rate of a human. This is an example of one-dimensional signal which consists of an information related to the electrical activity of the heart. What is the independent variable here? Here also the independent variable is time, whereas the dependent variable is the strength or amplitude of that electrical activity from the heart, which is usually measured in microvolts. Another example that I would like to consider here is electroencephalogram signals. Electroencephalogram signals. EEG signals. Let me show how this looks like. A typical EEG signal looks something like this. It does not have a fixed pattern as we have in ECG. There is no fixed pattern of EEG signal. This is again an example of one-dimensional signal. What is the dimension here? Here also the dimension is time. The independent variable is time, whereas the dependent variable is the amplitude, which is usually again measured in volts. Let's summarize what we have learned so far. Summary. Signal is a function of what? Function of one or more independent variables. We'll see more on this in the next module. Thank you.